Hi everyone. So we have this question under rotational motion and torque. Let's see how we can answer it. The question reads: a horizontal beam of length 10 meters and mass 100 kilograms rests on two vertical columns. So these are the two vertical columns. A box of mass 20 kg rests on the beam. This is the beam. From one end, it rests 8 meters from one end. Meaning that from this point to the point where the object is, there is a distance of 8 meters. So calculate the forces exerted by the two support columns. So the forces we're talking about is the force that is exerted here. Let's call this force F1. There's another force here as well. These are the two forces supporting this horizontal beam. Let's call this force F2. Now, since we have this object here, it means that there's gravitational force at this point. So we're going to call this, so let's just use mg. Now, the beam itself has a mass of 100 kilograms. So we're going to go to the center of gravity for the beam. Hence, the beam will also have gravitational force, which is mg. So I've just differentiated the two. This is mg for the box, this is mg for the beam. So to start with, we can look at, we can apply Newton's second law of motion, or Newton's third law of motion, any of the two. So applying Newton's second law of motion, we know that if we're in the y-axis, the vertical axis, we can say forces in the y are equals to mass times acceleration. So since there's more than one force, we can say the summation of forces in the y is equals to ma. Now, this beam is resting. It's resting, meaning that it has no acceleration. Hence, we can say the summation of forces is equals to 0. There's no acceleration. So now the forces which are going upwards, which is F1 and F2, will be positive. So we can say F1 positive plus F2 positive minus the forces going down. Let's consider them as negatives. So we have minus mg, another minus mg. All this is equals to 0. So these are the forces in the y-axis, and everything is equal to 0 because there's no acceleration. So let's call this equation 1. We'll come back to it. Okay, now let's apply torque. To apply torque, we first need to identify a point of rotation, a point where there's a force and where this object can rotate about. So let's assume that this object of ours is going to rotate about this point. So at this point, the force which is there is F1. Remember, torque is given by force multiplied by the perpendicular distance. You can say perpendicular distance. This is the formula for torque. So at each point where there's a force, then there's torque. So we're going to calculate the force, which is here, for example, and the distance from this point to the point of rotation. So this point that we've chosen here, this is what we've called the point of rotation. So we're assuming that this object can rotate about this point. So since we have 4 forces, we're going to have 4 torques. Now in this case, we're going to say the summation of the net torque is equals to 0 because this object, again, it's resting. Meaning that everything that we have, all the torques will be equals to 0. Now, how do we obtain those particular torques at each point where there's a force? At this point, the torque is 0, simply because the force, let me just demarcate this like this. The force is F1, but the distance from this point to the point of rotation, which is the same point, is 0. Hence, this will just get a 0. So, plus, remember we're summing them. So, we have to identify which force will produce a positive torque or a negative torque. And by that, we're talking about clockwise and anti-clockwise. Since this is our point of rotation, it means that at this point, what we're going to have is a clockwise torque. Same thing, at this point, we're going to have clockwise torque. But at this point, we're going to have anti-clockwise torque because of the direction of the force. Here, the force is pointing down, so clockwise. Because remember, this is where it's rotating about. if that's the case, then we can say we know that clockwise torque is negative and anti-clockwise torque is positive. So at this point, we can say force times distance. So what's the force? The force at this point is, so we can say negative mg multiplied by the distance. What's the distance from the point of rotation? Remember, the beam is 10, so half of that, center of rotation, is 5. Plus, this point as well, it's clockwise, hence it's a negative mg, the force, times the distance. So what's the distance? Remember, we said from this point to that point, the distance is 8. So 8, like that. Plus the torque at this point. So at this point, it's going in the anti-clockwise direction, hence it's positive. So the force is F2 and the distance is 10 because that's the distance of the beam. And all this is equals to 0. So if that's the case, then we can have this just a 0 as it is. So let's say on the left hand side, we're going to remain with 10F2. So left hand side will remain with 10F2. This is a 0. These two, let's push them to the other side of the equal sign so that they become positives. So this will become 5mg. This also go that side and it will become a positive 8mg. Now let's substitute those values. So 10F2 is equals to, so what is m? The big M, remember, is 100. So 5 times 100 times acceleration due to gravity, let's use 9.81, plus 8. Mass for the block is 20, multiplied by acceleration due to gravity, which is 9.81, like that. So let me just compute everything that we have on the right hand side. Let's see what we get. So 10F2 is equals to 6,474.6. So we're going to divide both sides by 10. Hence the value of F2 is simply 647.5 newtons. Okay, so now that we have that force, we can go ahead and calculate F1. Remember, we want the two forces. So we have F2. How can we find F1? To find F1, we're going to go back to this equation that we created here. So let's make F1 the subject of the formula. So what we're going to get here will be F1 is equals to, so mg crosses the equal sign becomes positive, plus mg crosses becomes positive, minus F2, like that. So if we do our substitutions, we're going to say F1 is equals to, the big M is simply 100 times acceleration due to gravity 9.81 plus 20 times 9.81 minus F2, which we've just computed, which is 647.5. So let's compute everything. We find the value of F1. And doing all the computations, what I'm getting is 529.7 newtons. So there we have it. We have the two forces that are supporting this beam. F1 is 529.7, while F2 is 647.5. Thank you very much. In case you have a question, please feel free to drop it in the comments. Have a good day.